Good to be with you here this morning. We are going to talk about testing in Xcode 5, or as I like to call it, why get a human to do a computer's job? We'd like to have the computers do the work for us, practice being lazy. Thank you for that great introduction. Jonathan Penn, Akron, Ohio. My parents moved to Utah down in Sandy last year, and I had the honor to come visit them with my family. We came out and spent the month in August here at the hottest part of the year. And so I prepared for hot times when I came out here today. Lo and behold, what in the world did you do with your weather? Because this is colder than Ohio. Crazy stuff. I write at cocomanifest.net. It's a great blog, in my opinion, exceptional commentary and resources for iOS and OS X development. And I own a company, Rubber City Wizards. We solve problems, and oftentimes we use software to do it. Enough about me. Who here writes automated tests of any kind? Okay, looks like about half the room. Who does that on iOS and tries to write unit tests, automation tests, things like that on iOS? Okay, half of that group. All right, because it's getting harder and harder. Yes, there has been friction to write automated tests for iOS applications. I have two goals in this session. We're going to geek out a bit on tools. There's some cool stuff that Apple's introduced in Xcode 5 that I'm excited about. Now, that said, those of you who've done a lot of testing in other platforms, I myself have done a lot of work with Ruby, JavaScript, and Clojure. I've done a lot of unit testing and integration testing in those platforms. And if you're coming to Xcode here from these other places, you're going to look at what Apple's done and think, is that all? And that's not an unwarranted feeling. Apple's a little behind. I'm not going to sugarcoat this. Apple's a little behind on making testing a first-class citizen on the iOS platform. It's been very difficult to do, a lot of friction. But I think I really like what I'm seeing now with Xcode 5 going forward. There's some cool stuff happening. You can see the wheels turning as Apple releases new stuff. Out of the gate, it's a lot easier to get started writing tests for your applications. If you've not done it before, it could not be a better time to get started. We'll take a look at that. My second goal, because it's nice that half the crowd here does not do much testing, may not have much experience with this, we're going to do it. We're going to write some tests. I have some examples that I'm pulling out from experiences that I've had writing actual production applications. We'll look at an isolated unit test for a formatting object. We'll talk about doing a simple integration test with a core data stack using the XCTest framework. We'll even look at what it would be like to test outlets and actions in a view controller that's loaded from a storyboard, all within the XCTest framework. These slides and sample code for all of this whole session are available right now at rubbercitywizards.com/stuff. Go there, download the resources, relive this marvelous experience at your leisure. So when we say testing, what do we mean? It's kind of a complicated topic because there's a lot of buzzwords around today. You might have heard these buzzwords, these schools of thought, things like test-first development, test-driven design, behavior-driven development, testing a developer's patience, driving developers mad. And my personal favorite, the one that I subscribe to the most, is fake it till you break it. So which of these schools of thought should you follow to guarantee success? You have busy work to do. You want to write good tests, write good software. What should I do? I regret to tell you I have no guarantee of success for you today. Writing tests is hard. It's just as hard as writing production code. You have to maintain it. You have to decide what's important to test. You have to choose the edge cases that you want based on your domain knowledge of the problem at hand. It's not easy, just like writing production code. It takes a lot of work. That said, now, the bottom three I made up, but the top three and other schools of thought are good to study because they give you practice. They help you increase your understanding, and I think it's important to look into these schools of thought when it relates to testing. But do not think that applying one of these will guarantee success. It's still just a lot of very hard work that you have to put into it. You're the one responsible for your tests. Another thing about testing that makes it complicated to discuss is it's a broad topic. There's different layers that you can test of your application. Like, let's say, top down, the whole way. This is what you do if you press Command-R and then run your app and tap around in the simulator. This is what the QA professionals do just before you ship. Big integration tests through the user interface. You can automate a lot of this using tools like Frank, KIF, or even UI automation. Quick plug for my book. And that's one of the ways you can do it, is testing the whole application. They call it integration testing because you're trying to see if everything all the way down was wired up correctly. You can do small integration tests where you take some of the separate components of your system and you want to see if they collaborate together well. Say you want to test that you're making proper queries to core data, that you're getting back the data you expect, that your data model is set up correctly. You can wire up a core data stack in memory using the in-memory store and then run tests against it. Create some objects, try to save, see if you have validation errors, all that stuff. With these, I call these component integration tests, because they're not, usually when you think of integration tests, you think of the full stack, but this is like just smaller components collaborating together. And underneath that, we have isolated unit tests. This is what the holy grail of testing is, because basically you have isolated small units that don't necessarily collaborate with anything else, or maybe they don't need to collaborate with many things, and you're able to instantiate them, give them input, see their output, and assert that the output's the way that you expect. So here in this talk, we're going to be focusing on these two things, component integration tests and lower level isolated unit tests. I think big integration tests are important. I wrote a book about it. But that's beyond the scope of this talk, and as of today, Xcode 5 does not necessarily move in that direction. It's better suited for these two types of tests at the bottom. Here's an example, actually drawn from some work that I did on another application. Let's say that you have an awesome app. You're trying to delight your users. You want them to understand durations of time. But you store those durations of time as seconds in your core data model. So to display it to the user, we'll follow Apple's lead. They have NS number formatter, NS date formatter, and here we're going to use time interval formatter. We'll create an object that when you instantiate it, you can pass in a number of seconds to a method, and boom, out comes a string looking something like this. Here we see 5M20S. Now we want to make sure that if we ever pass in 320 to this method, we get this output. So we write a test that makes an assertion that says this should never change. Lo and behold, this test passes. Go figure. And the beautiful thing about this test is it feeds back into our application development cycle. Let's say now that you go in and want to add a new expansive feature to this formatter. We need to be able to format hours. Users are using the application. Whatever we're measuring now lasts in the span of hours, and we want to be able to say that you have 2H, 5M, 20S, whatever. So we go and implement that. Uh-oh, but when we run our tests, something broke. For some reason, when we pass in 320, we get 320S back instead of the 5M20S that we expected. We must have left out an if statement or changed something in the process of growing the application that broke this test. And this is where tests can be awesome. It's a virtuous feedback cycle, like a long-term memory that helps you remember things that you might have forgotten just before you ship. We're used to feedback. We do this all the time. Whenever you press Command-R, fire up the simulator, and click around to see if it's doing what you thought it was doing, you're looking for feedback. Tests are like that, but at a much smaller level and a much quicker feedback cycle, and you have a bunch of them watching your back to make sure things work. Testing is kind of like double-entry bookkeeping. Your application is in one ledger, your tests are in another, and then hopefully you're maintaining balance, and they're checking your work. Yes, this means that you are writing twice as much code as you would if you didn't have tests. If you're nervous about that and skeptical that this is worthwhile, good, you should be. Writing code is not a guarantee of good things necessarily. However, I think that if you focus on writing tests that target certain parts of the application that you're concerned about, it can be a very effective way to help you ensure quality. The important thing to remember is that tests do not guarantee correctness. I mean, this is Objective-C. We're not talking Haskell here. You're not going to have mathematical purity of proving what your application does. But we can raise our confidence. We can choose certain things to test. We can say, this bug has happened so many times, I'm going to write a test about it. And then if it ever happens again, I'll know before I even ship. Or maybe you know ahead of time, ooh, these are edge cases. You know what? I can write tests around this stuff, and if I ever accidentally break it, those edge cases will be covered. We'll see that in the demo here in a moment. Tests also help with hygiene. I like this picture too. It took me a while to find it. It's on iStockphoto.com. I'm not guaranteeing that tests make your code better. I think sometimes there's some snake oil being sold in the testing community about how you want good code, you need tests. You can have good code without tests. What I'm trying to convince you of, though, is that growing an application, making changes over time, can be very well helped by having the long-term memory that tests provide. I'm not guaranteeing your code is going to be clean. You're going to still have to apply it. But going back and making changes to keep your code clean can be very effective when you have tests catching the errors that crop up as it naturally happens. I'm not accusing you of being bad programmers. We're human. We make mistakes, and we'll even see that in the demo. Enough talk. Blah, blah, blah. Let's dive in. All right. Questions so far? You can feel free to heckle me. Oh, man, a little taller here. All right. I am making a very strong plea to the demo gods today. I'm quite nervous. We'll see how this all works out. All right, Xcode 5. Beautiful thing about Xcode 5 is when you create a new project, you get a test target bundle or a test target in your application project for free. If you've done any testing before using the XCTest framework, you probably saw that little checkbox saying, oh yeah, create a new project, would you like to have unit tests with that? You don't even get a choice now. You get this awesome little testing target. I'll show it here. You can add a testing target if you want by just choosing Add Target, and then you'll see the Cocoa Touch unit testing bundle. All you have to do is create that. It adds these extra files here into your project, and then a blank test that has a failing assertion down at the bottom just to get you started. Really, really easy. If you've tried to do testing before, it can get kind of complicated, especially if you were trying to add tests to an existing application. Xcode 5 takes away a lot of that friction, and I'm excited about this. This helps raise the level of discourse. We can now say, okay, before we can talk about testing, you got to set it up. Well, we can get all past that now, and we can just talk right about testing. What we're going to do is I'm going to delete this test here. I don't need this test file, but I want to create a new one. We're going to create a test and grow our time interval formatter by doing test first development. To do that, I'm going to create a test file. Go here to say I want an Objective-C test case class. Double click it. We'll call it RCW time interval formatter test. Subclass of XCTest case. That's required. The name of this is not necessarily required. You can name this whatever you want. The fact that its subclasses are XCTest cases where the magic happens. It's conventional, though, and I think Xcode even does some introspection into this. If you name the object that you're testing, or name the test after the object that you're testing with the test suffix. That's a general convention. If my understanding, I think Xcode uses that for some introspection for the assistant editor to be able to jump back and forth, so it's a good idea to do that. But you don't have to. You can write a test that's not against a specific object, and you can name this thing whatever you want, and it'll just work. Click Next. Make sure that the test target is selected here. You don't want your application target selected. You can't link this against your application because it depends on the XCTest framework, which does not exist when you're going to ship this thing in production. Bad things will happen and you'll get confused, so just don't do it. We'll click Create, and here we go. We have a test file. We'll get into setup and tear down in a bit. I'm just going to go ahead and delete these. And I'm going to close this sidebar and raise this up a little bit. There we go. What this here is we have this file called RCW time interval formatter test. Its subclass is XCTest case, and then magic happens. Whenever the subclassing happens, it gets registered with the test runner, and then the test runner goes through all the methods of these test case subclasses and looks for any method that begins with the word test. This then becomes a test step that gets run, and you make assertions inside it based on whatever outcome you want to see. Here's a very simple assertion to help maybe remind you where you left off. We can just say XCT fail. This will always fail the test. And when it says no implementation for S, this is an error message that is only printed out when it fails. But since this is a failing assertion, we'll see it all the time. To run your tests, you go to the product menu and you choose test, or press Command U. Get to know that command shortcut because it will be your friend. It goes a little faster on the Mac, but for iOS apps, it launches the simulator, and boom. All right, we have this nice little error. If you've done XCTest before, or even the other things built on top of it, like Kiwi or Specta, you'll see the similar implementation here. Our tests fail, and we can jump right in and find out what went wrong. But the new goodies what you have with Xcode 5 are these little icons in the gutter that show you what test failed, and you can even click it to run just that specific test. There we go. If you've ever tried to run specific single tests with XCTest before, you had to go into your scheme and uncheck a bunch of other stuff. It was a big pain in the butt. But this is a lot simpler now. It reduces the friction to isolate what you're trying to focus on with your tests. Good stuff. We also have this special sidebar lozenge you can click here. It brings up our tests, all of our tests. As we add more tests in subclass XCTest case, they're all going to show up here in the sidebar. You can even click the individual tests to run them. If you want, it's a great way to see what's going on, and you can get a grand feel of all the tests going on inside this target. All right, so we're ready to go. Let's write a test for our pretend RCW time interval formatter that does not exist yet. When you start writing tests, and when you're doing something like test-first development, start with the simplest case. We're going to write a test and then write production code to make that test pass. And that's what we're doing here. We have an RCW time interval formatter. We're going to pass in a 0, and then we're going to expect that something comes back like this. We'll say XCT assert. Output is equal to string 0s. Now, we can't test this yet because the compiler is going to complain at us. We don't have an RCW time interval formatter at our disposal. So when I do test-driven design or test-first development, I like to just keep things as simple as possible. I don't want to go back to the project sidebar and create a new file and throw things in there. I actually like to do some experimentation within the test file itself. Just keep it all here. I'm not even sure what I'm going to keep when I'm done. So we'll just, rather than creating a whole bunch of stuff that we depend on, we'll just do it right here in line. I'll create a little, there we go, create a little comment so we know that we're separated. And then we'll paste in the simplest implementation that will satisfy the compiler. We press Command U to run. It compiles, it runs, and it says a message here. Output is equal to string 0s is true, failed. That terrible English is telling us that the assertion we were making, output is equal to true, or output is equal to string 0, we wanted to make sure that was true, and it's not. That assertion failed. This isn't very useful to us at this point because we don't know why it failed. It'd be nice to know what output is. And we can do that by using these special extra parameters of the assertion macros. Any string that you put as the last parameter after all the parameters that your assertion needs will be used as an error message. If the test fails, this error message will be printed out, and lo and behold, it is just like the string with format. In a string, you can pass in extra parameters that get interpolated in with the format specifiers. Now, those of you who've done send test before, you know that these methods were required, and you had to specify nil if you didn't bother with an error message. You don't have to do that now. Apparently, Apple hired some awesome preprocessor macro fiends who were able to leave that out, and you can ignore it. I like this stuff. You write less code to make things work. So we run this, and we'll see a failure. Close that sidebar there. It says output is equal to string true, failed, expected null to be 0s. Great. This is the error we expected to see because we're returning nil from our, delete this here. We're returning nil from our string with from time interval method up here. Now this method is still nice. We're able to specify what we expected to see. We can see it in the error message. It gives us better feedback. But Apple has given us a better way to do this. We can actually just say, I want these two objects to be equal. And that's what we'll do here. By saying XCT assert equal objects, it does the is equal to comparison for us, and it even formats an error message if this is not the case. We'll run our test now with Command U, and it says, we'll hide the sidebar so we have more room. Output is equal to 0s failed. That's a better looking assertion message, and here is what happened, what went wrong. Null is not equal to 0s. The same error we expected to see, no surprises here. Great. Let's go make it pass. How do we do that? Well, like this. If you're not familiar with test-first development, you're probably going to say, wait a minute, that doesn't work. I mean, yeah, the test passed, but it doesn't work. And you would be right. But the idea is, in this school of thought, let's wait to implement what we want until we have a test that tries to help us actually need that thing. We'll write tests later to cover other use cases, other seconds and minutes and days and things like that. So this, if we press Command U, we expect that the test will pass. If it doesn't, that means one of our assumptions is wrong and we need to go back and check. I think it worked. I didn't see anything here. Hey, look at that. Green checkboxes mean happy things. So the test passed and we're good to go. Time to move on. We're going to be having a lot of tests that use this time interval formatter. It'd be nice if we could have some way of instantiating these time interval formatters in a common way, that we don't have to do it in every single test step that we have. So lo and behold, we can use the setup method. Setup and teardown, they do kind of what you'd expect. They are run before every single one of these test methods is executed. So they give you a chance to set up state. The teardown method is run after every one of these test methods is executed. You can clean up. If you're doing any writing to disk or anything like that, you can go clean it up afterward. In this case, we have a property. We have a property on our test case object. These are just NS objects. You can organize things any way you want. And then in our setup method, we instantiate a formatter and set it to that property. And then here in our assertion, we're just saying string with interval, string from time interval 0. And now we're ready to write our next test for 10 seconds. No surprises here. Passing in the number 10, and we're expecting 10s. Now, it's nice when you do something like this, you're growing your tests and your code along side by side. Call it when you think it's going to fail. Because, again, part of what we're doing with this is testing our own assumptions. I am pretty sure this is going to fail because we're only returning 0s. Yeah, I know, it's a demo. We're kind of like, it's nice and simple here. But as you're working with more complicated pieces of software, it can help to just say, I think it's going to fail because of this. And then if you're wrong, you can go back and check your assumptions before you move on and then get lost. And it's failing because it says 0s is not equal to 10s. Excellent. Let's correct this and make this test pass. The simplest thing to do to make it pass is just return a string with a format specifier that just lops off any extra digits. And we'll just truncate it to the integer and pass in the interval. Apple does not recommends not using string with format for user-facing numbers. They recommend using NS number formatter for localization reasons. It also is a great way to specify the rounding rules that you want to have. We'll get there in a moment. Right now, we just want to make this test pass. We can go back and adjust things later when we're sure that these two use cases are covered. Command U. And succeeded. All right, both our tests pass. Moving right along. Let's go implement that NS number formatter now. We've made the test pass. It's doing kind of what we want. So now let's go rip out our implementation and completely redo it. Select all this, paste in new stuff. Here we have our number formatter as a private instance variable. We instantiate it. We say we want the decimal style, round half up. That seems like the common pattern for rounding nowadays. And we don't want any fractional digits. We want to truncate off at the decimal point and just return what looks like integers. In our string from time interval method, we box up the interval in an NS number, pass it into our formatter, and boom. We still need to use string with format because we're tacking on this s at the end for to represent what the second's duration is. Let's run this. We just re-implemented our formatter. We ripped everything out and started over again. And it works. Awesome. Let's move on. All right. Next test. Time to do minutes. Thus far, our application only needs to display minutes and seconds. So that's what we're going to do. And I'm arbitrarily picking this here. We're going to test for 3 minutes and 10 seconds. What should you pick? Well, this is a trade-off. You need to kind of know your domain that you're trying to solve here. You know what edge cases you want to test. I'm content with this. I'll just say 3 minutes and 10 seconds is sufficient. We pass in this little equation here, which generates the number of seconds, and then we are making an assertion for 3m10s. I think it's going to fail, because it's going to return some huge number of seconds. I think it's 310. Or 190. Here we go. The failure is 190s is not equal to 3m10s. That's kind of what we expected. Go back up here and make this pass. It's getting a little complicated. We have to swap out this implementation with some math. We're now extracting our minutes and seconds using this kind of like made-up thing. I'm brute force hacking it. It's okay to hack around when you're writing tests because I have test coverage for the expectations that I want to see this thing do. I'll go back later and clean it up. So I'm just extracting minutes and seconds. I have an array. If there's any minutes, then build the format string and add it to the array. Always do it with seconds. And then join that array with a space. This is enough to make the test pass. Press Command U. Oh, nice. And the demo gods said, no more jokes about Xcode. This could be fun. You've never seen me improvise before. Oh, boy. Oh, boy. Good times. Dave, would you help me file a bug right now? Yeah, that probably will work. Okay, for now, this will work. You know what? Since you said that, I think it's a good idea. We'll go ahead and uninstall anyway, because the next time we run, it'll pop back in there. I think, yeah, there we go. All right, we're good. Our tests pass. Here they are. All 3 of them are good. Our 3 minutes and 10 seconds is handled just fine. Now it's time to test an edge case that we might have forgotten here. What happens if we just pass in enough for just 3 minutes? Well, according to our user studies, or whatever else we're doing to try to figure out what the user wants, I hope you're doing that, then you have 3m here. Oh, sorry, that's hard to see. What? There we go. If we pass in enough seconds that just round off to 3 minutes, we want to say 3M and leave off the 0 seconds. We have found that that's the least confusing thing to the user, and we're just going to roll with it. I expect this to fail because we haven't done anything to exclude the seconds. It should say 3M0S. Let's see if it does that. There it is. Failed. 3M0S is not equal to 3M. Get rid of that sidebar. Head back up. Whoa. Where did, oh. Whoa. That was scary. Bugs galore. I'm sure it's my fault. All right, we're going to replace the second string here, this place where we're making this, we're just assuming that all the seconds need to be included. We'll replace it with this. If seconds is greater than 0, we're making the same kind of check before. You know, if seconds is greater than 0, then we want to include it. But we also want to include it even if there's no other components that we extracted out. And this is because if the user passes in 0, for some reason we're trying to represent 0 seconds, we don't just want an empty string, we want 0s. And this is a quick and dirty way of checking for that, because we're adding all the components that we're generating, all the formatted strings to this array. We'll just check for its count. So I'm expecting this to pass. Are my assumptions correct? Yes. All right. We're doing great. Now, lo and behold, Sally comes to me. She's on our team and working hard, and says, Jonathan, do you realize that you're doing all this work to extract date components yourself? Apple's done it for you. They have this awesome thing called NS Calendar and NS Date component. Sweet. Why reinvent the wheel? I want to use what Apple's doing, which means I'm going to completely re-implement my time interval formatter as I had done before. So we go in here, we have a new, a private variable for NS Calendar. We instantiate it here in our init method. And now we get to the magic. To set up a bit flag to say that we care about the minute and second units. And then we ask the calendar to give us date components that are from now to now plus some interval of seconds into the future. This is a quick and dirty way of just saying, hey, I want the date components out of this time interval. Once you have these components, you're able to do things like saying, hey, give me the minute component, give me the second component. And then I'm going through and then doing all the work to say, yeah, you know, if there's any minutes, show them. If there's any seconds, or if we've not shown anything else, then show them there too. And we've completely re-implemented this thing from scratch using NSDate component. Are the tests going to pass? I think they are. Is Xcode going to run? Please do. Hey, and it worked. All right. Yay, test pass. So we decided to re-implement it using the more official method that Apple provides. We're letting Apple take care of all the edge cases about extracting components. But the things that we were worried about, if we pass in these intervals, these are the strings we want to see when they come out, we know that those work. Our long-term memory is serving us well. All right, moving on. Time to test hours. 2 hours and 20 seconds. We're now, our test code here is getting more complicated as we generate longer and longer intervals. We're expecting to see 2H, 20S. And what I think is going to happen is when I run this, we're going to see a ton of seconds, or a ton of minutes, and then a few seconds. And that's what we have here. 120 minutes, 20S is not equal to 2H, 20S. Well, no duh. Let's go implement that. To do that, we have to copy. Here we go. We'll create the consumption of the hours component, but we're not done yet because if I ran this as is, thinking I was done, it'll still fail. In fact, a lot of things failed, a whole bunch of junk. Look, whoa, 21 million hours? What is this? You know, whoa. Now, sometimes this happens. When you're writing tests and you're writing your code, you do something and then all hell breaks loose and all the texts crash. Well, in that case, it's time to stop. You don't want to keep going. You're going to lose your place. You're going to get confused. And we can at least undo what we just did, test pass, and then we know we have a baseline and move from there. And what we're going to do, though, is we realize as we check the documentation, we forgot to say NS hour calendar unit in our bitmap mask, and then we add that in, press Command U, and everything passes. Boom! There we go. Build succeeded. All green. Check in the sidebar. If we have so many tests that you can't see them in one file, you can check and see that they're all green, and we're good to go. Time passes. Users now have enough time represented in the application that we have to track days. Well, I'm going to be a little snarky. I'm just going to say, let's test 9,336 days, 3 hours, 20 minutes, and 10 seconds. Why? I wanted some absurd edge case. This gives me I think that this gives me enough coverage, given what I know about the domain of this object and what it does. I'm just going to write this, and this will help us make it work. This will fail because we're not extracting out the day component. Some obscene number of hours, is not equal to whatever this string is here. Yeah, we got to go fix that. And all we have to do is paste in the day component extraction, and then use our newfound knowledge of the documentation to add it to the bit mask. Press Command U. Ta-da! Tests pass. So the users finally reach over 1,000 days, and then they say, wait a minute, where's my pretty comma separator? I really wanted to have, formatted the way I write it on paper. What's going on with this? So they start filing bugs, and we go back and think, wait a minute, didn't we start using NS number formatter? Why aren't the comma separators there? When we rewrote it, we left it out. All right, well, no problem. We'll just go in. We'll update our test. That if you have something that's long, that needs a comma separator or some thousand separator, we'll just add it in. We're changing the test. We'll run. We'll watch it fail. We're expecting it to not have the comma, and that's what we get. The 9,336 is not equal to the thing with the comma. We then go back up to the top, and we want to implement this with the NS number formatter. I'm going to cheat due to the magic of television and just paste this in here. Our NS number formatter is back. We instantiate it the same way we did before in the init method. And while I'm writing this, I'm realizing, there's a lot of reuse I can do here. I'm making the same kind of assertion. I'm going to extract this out. I'm going to pull this if statement out and the normal formatting, and I'm just going to make it this method I can call on myself. Components day, hour, minute, second. If any of them are greater than 0, they'll show up, and it'll just work, right? Extraction, dry. This is what we do all the time as programmers. Let's run this and see if it works. I'm expecting all the tests to pass. Uh-oh, what broke? Let's come down here. Oh, this is weird. It says output is equal to 0s. Empty string is not equal to 0s. That's crazy stuff. What happened? Oh, no, we forgot. In our haste to extract and generalize, we deleted the special exception for seconds. If there are no other components that were extracted, and even if there are 0 seconds, we still need to return 0s. Rather than trying to hack this generalization here and add it into this, we'll just do it here. If parts count is equal to 0, then, there we go. Then we'll just return the constant string, hey, come on, fingers, 0s. Press Command U to watch it work. Boom. If I wanted to go back now and clean this up, maybe I wasn't happy with the way I extracted this out, I can. I can refactor, do everything I need to do. And the tests are covering me. That's my long-term memory. Happy, happy, joy, joy. We're good stuff. Ship it to the user and make money. Now, we can't ship it yet, because here we've just developed this time interval formatter within our file, our test file. Nothing else in our application can see it yet. We need to extract it. New file, Objective-C class, RCW time interval formatter, subclass of NSObject. I'm content with that. I have to add it to my testing target. Otherwise, my test can't see it. That wouldn't be good. Create that, and now I'm going to go in and start doing copy-paste, which is always scary, but I have tests to cover me, so I feel pretty confident. Of course, I made, we need to, because we're doing this in the same file, we haven't had to worry about actually exposing what methods we're calling from our test or from the rest of the application. Put that method definition there, and we'll grab our implementation. I hope that you use Git. You can roll back if you cause big problems. Paste this in here. All right, press Command U. Will it pass? No. Unknown type name. We got to import it in here. Import RCW time interval formatter. Command U. There we go. Test first development for a time interval formatter. Extracting it out. It's ready for the application to use. Ship it. Good stuff. Any questions this far? We're blowing through this stuff pretty quickly. Anybody concerned? Yes, Jeff. Oh, mock objects. A mock object is a stand-in to help summarize what the question Jeff's asking. When would you use mock objects? Think of it this way. You have a view controller that talks to a network. Ideally, you would have your view controller talk to another object whose responsibility is to fetch things from the network. That object then talks to NSURL request. What you can do with special mocking libraries, like say OCMock or some of the things bundled with Kiwi and Specta, is you can mock out NSHTTP request and hand that mock in to your special object whose responsibility is to talk to the network. Your mock is completely under your control in the test environment. You can make it return whatever you want, which guarantees that you have consistent results coming out of your object under test. So I think that's a very important thing to do because you're making your tests reliable and not dependent on some external API. You can make your unit tests talk over the network if you want. I would not recommend it. It might make them slower. Having fast tests that you run really quickly is very important. It's that fast feedback loop, long-term memory thing that I'm talking about. But at the end of the day, when do you use mocks? When you have pain. If you have collaborators that you don't want to talk to while you're testing, use mocks. The problem is OC mock does not yet work with Xcode 5. At least there's some kinks involved with using it with a new 64-bit iOS thing. He has a plan, and he's going to be releasing documentation to use OC mocks, but he has to wait for Mavericks to come out because that's when the NDA will drop and he can share screenshots. And it's not built into Xcode 5, so it's something not quite that I was going to cover, but I think that's important. Mock objects are a way of saying, I don't want to talk to this collaborator, but my object under test needs to. I'm going to hand in a fake, and I'm going to make that fake thing do what I want. I can even make assertions on that fake thing to make sure it was talked to the way I expected. That's a subject for another time. All right, let's use more magic of television and check out my next step. So let's say that you're writing these small little unit tests, but then you think, I'd like to test some bigger things. Like, I don't know if I'm writing my core data model correctly. I want to protect against changes that might break things down the road. I'd love to also test the queries. Am I making queries correctly? Well, let's explore how that might work. This version of the app is evolving. It's now a journal app. Don't ask me how it's evolving this way. It just is. That's the beauty of demos. I can make things up. So we have this journal entry object that has a body, title, and when you created this journal entry. I'm not trying to compete with day one. Just want to point that out. But if you were, you could do something like this. In this core data model, all these attributes I'm marking as required, which means in my test, I would love to make an assertion that if I tried to save one of these journal entries, the save would fail. And I can go check to see that I had the right validation error and things like that. We also have journals having many tags, so I'd love to make sure, I keep forgetting the syntax for querying based on relationships to other objects. I'd love to write a test to make sure I'm doing it right, and I'm going to put that here and create enough objects that I can do that in my test environment. We'll go here to core data model test. I'm going to kind of wave my hand and say, pay no attention to the man behind the curtain. We'll get to some stuff that here in a moment, but let's just look at this from the top down. I have my core data model test object. It says test journal entries. Somehow I make a blank journal entry. We'll get to that. Just bear with me. We have an empty journal entry, which means that if I call save on my context, it should fail. That's why I'm saying here with XCT assert false. I want to make sure that this doesn't work because I'm expecting a validation error. Then the very next assertion I make is to check the error code. It should be equal to 1560, which is the Cocoa error message to say, hey, yeah, this is a validation error. Notice I'm saying assert equal and not assert equal objects. That's because I'm comparing two C primitives. You don't want to use assert equal on NS objects because if it worked, there's actually a nice compiler error now, but if it worked, what you would be comparing is the pointer addresses of these objects, not their actual equality within the semantics of those objects. So remember this, assert equal objects and then assert equals. And there's also other ones, if you're comparing two floating point numbers, you can say assert within a certain delta, things like that. We then assign properties to our journal entry. We try to save, and we're expecting the save to pass. XCT assert. We're asserting that this is true. If it doesn't, for some reason, well, we'll print out the error object that came back, and then we can go figure out why and fix our test or our code, depending on whichever one is broken. Now, yes, this is not a very thorough test for validation errors. I could take this error message or error object that I have back and break it open. Validation errors are actually errors with a bunch of errors inside of them. I can go check to make sure that all of these fields are properly triggered by the validation checker in core data. But this is just enough to show you that what's possible. You can fire up entities, in your core data stack. We have this property called self-context. This is probably a good time to say where that came from. What I've done here is subclass a special thing I made, some secret sauce, called RCW Core Data Stack Test Case. We're getting into the nice long names, specificity of Cocoa Touch. This test case class does not have any tests inside it. All it has is a setup method which is called, and I'll have to call super setup just in case there's anything that the superclass has to do for setup as well. Here, I'm instantiating my managed object model, my persistent store coordinator, and I'm using an NS in-memory store type. Great use case for this with core data. And then I instantiate my managed object context, set up my coordinator, and then I have a couple of helper methods that go through all the crazy long stuff for making the NS entity description and pulling out these particular entities. These things make empty managed objects that I can then populate. You can mix and match this to whatever your heart's desire. This subclass is now reusable for many different classes of core data tests. It's a great way to kind of bubble up, move the general things up to the superclass, keep your specific things down to the subclass. You'll notice that when I run these tests, this test case class shows up here in the sidebar without any tests, of course. That's just an artifact of that it's subclassing XCTest. It's registering itself as a test case, or as a test suite that needs to be run, but there's nothing in there, and that's okay. It's just, you just ignore it and move on. And I named it appropriately. I'm not calling it a core data stack test. I'm calling it a test case. That's a cue to myself that this is something reusable. I can build a whole set of other tests on top of this to help me with reuse. All right, the next test we want to do with core data is queries. Make an empty journal entry, fill it with some data. Make an empty tag, add the journal entry to that tag, and set the tag's name to family. Make another journal entry that's not a member of that tag. Assert that we can save. If we can't, we probably shouldn't go on yet. We need to go fix something and figure out why. So assert that save as succeeds, clear out the context's cache. We want it to start from scratch and go fetch things from the persistent store. Build a fetch request that says search for family in tags.name. This is my check to make sure that I'm querying core data correctly, according to the schematics of my entity diagram. This could be pulled out. Maybe a separate object is responsible for building these queries. Maybe this is a stored query within the model itself. But this is a great way to test your queries to make sure you understand core data better. I've used this method to actually learn about core data, to try different ideas. I've created a test file, my own little project with a bunch of test cases that I put my learnings in there. It's kind of my own version of long-term memory. It's not part of a production app, but it's my own way of remembering how to do things with core data. We make a request asking for the results back. They should not be nil. We need to have results. There should only be one. If there's two, that means we made our query wrong and both of these entries came back, which is not what we want. And check my entry and look for the title, make sure it's the one that I expected. Again, I'm making a decision based on my domain knowledge of what I'm trying to solve here. I think this is a sufficient test for this use case. You might need to get a little more nitty-gritty with this depending on what you're trying to do, but that's up to you. You have to make the hard decision of picking the edge cases that you want to catch with your long-term memory and tests. That is a component integration test using the XCTest framework. You can wire up whatever you want in memory, hook them together, exercise them, and then check the results. So what would it be like if you wanted to test a view controller? I don't necessarily recommend this, but we'll do it anyway. The application I have here is really simple. Simple initial view controller with a button and a label. You just click this over and over again, 1, 2, 3, 4, 5, 6, 7. What we're going to do is assert that if you were to click this button, that the label gets updated over and over again. To do that, in our root view controller test, we inherit from XCTest case. We have our controller properties, so we're ready for reuse. We set up that controller here by grabbing the storyboard, instantiating the initial view controller, and we have to call view. Because when you first get an empty view controller ready to go, nothing's wired up. No outlets, no actions. If we were to comment this out and run the test, we would be told that all of these properties here, the text properties of these labels, are null. And the reason why they're null is because the property itself hasn't been wired up yet. By calling view, we are now triggering all the magic things that happen that Apple does when they wire everything up with view controllers. It calls view.did_load, and that's when we set up some of these things. And now we go through, we check first our initial state should be clicked equals 0. We initiate the click by literally calling the action, button clicked. That's completely legal. I don't use the sender in this method, so it doesn't matter what I pass in. I can pass in anything I want. Now, I do have a little, I mean, I wrote this object that I'm testing, so I know some of the internal schematics, and I know that I don't have to pass anything in. That's part of my own domain knowledge of the problem. I then check to make sure that the counter incremented. I call it again, make sure it incremented one more time. I'm just doing that for fun. You can do that same assertion as many times as you want, whatever you feel comfortable to feel like you've covered the bases. And we run the test and they pass. The problem with this is that the view controller mechanism is, there's a lot of magic that happens there. I knew from experimenting with this that I had to call view to get this set up. This does not call view will appear, or view did appear, or even view will or did disappear. You have to call that stuff manually today. We don't know what Apple's going to be doing with iOS 8 or 7.1 and beyond. When iOS 6 came out, a whole bunch of things about view controllers changed in ways that broke tests that I had for view controllers, because I was making assumptions about how to set them up. So that's one of the dangers of trying to test an object that you don't have much control over. In practice, while this may be useful to test that, it's certainly possible to test that you've wired up objects, actions or and collections or outlets properly, because those break a lot when a lot of people get into storyboards and nibs and try to move things around. Testing actual behavior of a view controller gets really complicated. I would recommend extracting the stuff the view controller does into other objects and test those instead, and then have the view controller just be a dumb wiring up thing that helps everything coordinate together. If something breaks in the view controller, that's fine. The footprint of where the bug could live, you have a greater confidence that it's not inside the objects that you tested. You think it's probably just in the view controller, and you can go check it out. So. All right. Next, my favorite feature of Xcode 5 is the whole bots thing. Who here does continuous integration? Not necessarily with tests, but with anything, with your iOS applications? All right. Well, you're all going to love this. It's good stuff. I've done a lot of work with Jenkins and Travis CI. I still like them. There are some things that Xcode Bots cannot do. We'll get into that in a moment here. So what you do is you have to buy a Mac Mini or some other Mac. You can buy a nice Retina MacBook Pro and have nobody use it and just set it on the shelf if you want. That would be funny. Convince that to your CFO. And then you put a Mac up, you set up Xcode server on it, you set up OS X server on it, you set up Xcode on it, you get it set up with all of your certificates and your developer account and things like that. And then while it's running over Bonjour, you can go and say create bot, and Xcode will go find that server. Now, through the magic of television, I happen to have a server running in a VMware VM. So I went and set this up ahead of time. I told this server where the Xcode repository was. It happens to be on GitHub. You can host the repositories on this yourself if you want. That's a great way to do it. Setting it up to talk to Xcode requires using SSH keys, and it's possible. It's not hard. It's just a lot of steps that weren't important to this talk, so I'm glossing over it. So that's running in the background. The server is automatically seen by Xcode, and I can say next. I want it to do it every commit. Now, in this case, because it doesn't own the repo, it has to go and fetch the repo. It says here every 5 minutes. And then if it sees new commits, I'll run an integration. And then I want to do these actions. I can even say to clean. Sometimes cleaning before integration is good. Gets rid of all those strange build artifacts that might linger around and cause problems. Click Next, and you can say what you want to test. You can hook up iOS devices to your Mac Mini, and it will run your tests on them, which is awesome. Because I'm in the simulator, or in a virtual machine, we'll use the simulators. I'll click Next. You can say who to yell at when things go badly. This is great. Put your CEO in there, and you'll have great quality code. I would not recommend it, actually. It's kind of annoying. Because then he comes down and does what managers do, like, harder! Beatings will continue until the morale improves. It just gets nasty. But what you get at the end is this nice little, whoa. Here we go. Oh, sorry. Let me, if I can raise up this, yeah, there we go. Raise this up. We don't need all this screen real estate. Okay. Here's our testing an Xcode 5 bot that I already created earlier. It keeps track of all the past integration runs. So thus far, over the last 5 times, I've had no test failures. Woohoo! I get a free watch or something like that. And every time it sees a change, it will run a new test. And Xcode notices that and watches, and you can watch the test or the integration happen in real time. Here in the tests, I can click on one of these integrations and say, I want to see what happened here. It shows you all of the devices or the simulators that it ran your tests on, which is awesome. Theoretically, your unit tests should not be affected by architecture because, that's the beauty of what Apple's been doing with LLVM. They're trying to even things out and keep everything consistent. All you have to do is rebuild and stuff should just work. But in the real world, there are byte alignment and all sorts of things that come up. Sometimes, people are human, compiler errors, it just happens. So it's nice to know that you can run this on all sorts of stuff, and even processors. It tries to run it against the x86 64 iPhone Retina that many of you might have. So it's beautiful stuff. Now the problem is you cannot have a bot trigger an external thing that then can also fail the build for you. This is a problem for me. I use UI automation that Apple provides with instruments. I cannot make a UI automation test fail an integration build on an Xcode bot to this date. I have a radar filed. If you'd like to join me in my quest, we can file radars together to get this thing done. This would make Xcode bots far more useful for many kinds of things. For integration, full stack integration tests like UI automation and for other things that say we want to trigger the build fail for some other reason. Maybe we have a special check in the repository. You left a certain asset out that you want to make sure is there, however that works, for legal reasons, things like that. You could theoretically write an external script to make it fail. Jenkins is awesome at that. So if you still have that in your process now, or if you need to have Jenkins watch other things, you're going to have to stick with it. Xcode bots are specifically targeted to Xcode, and at the time being, there is no way for you to help fail the build to communicate back to you that there's something that you need to fix. So. Woot! Woot, woot, woot. Any questions about Xcode bots thus far? People going to use this now? Will this drive you out to buy a Mac Mini? Because you know that's why Apple did this stuff. Genius. Genius. All right. Some resources to take and then go forward with this. I'd recommend the book Test-Driven iOS Development by Graham Lee. Marvelous book. It's a little cerebral. He walks through a lot of the methodologies, and he actually tries to demonstrate good test-driven development practices on iOS. He did it. It's an older book done in 2012. He did it with the Sen test framework, so I give him huge props for that. Just a few of the names of the assertions change. Pretty much everything you see him doing in this can translate to XCTest just fine, and I recommend checking it out if you want to get into it more. Support him. He's an incredible guy. He's like a historian in the computer world, and I love him. OC Mock, I'm linking to it here. When there is support, if I ever do this talk again, I will talk about it because I think it's important. Mock objects are a great way to help you conceive of separating your app and trying to isolate as much as you can when you're writing tests. You don't want to have your tests depend on the existence of an API. You can't run your tests offline. If they change the API, whoops, your tests break and it wasn't your fault. It doesn't help at all. That's not the feedback you want. Mock objects are a very good idea, but the theory of how to use them and organize things well, that's actually pretty advanced, and there's some great tutorials to understand how they can be useful on the ocmock.org website. Code coverage tools. Code coverage is the idea that you use the cool awesomeness of the profiling debugging tools that come with your code to watch execution and check to see what lines were actually called by your tests as they ran and what lines weren't. At the end, when you use code coverage tools and run them with your tests, they will spit out some sort of ratio, like 80% of your code was executed in this test run. That's very useful feedback to help you understand what you might want to go look at to check to see, hey, I didn't cover this. Why not? Maybe I need to go cover this thing. Yeah, 5 minutes? Thank you. Awesome. So, good. I'm almost done. The boredom will stop soon. The problem with code coverage as a metric is that it's often used by management as a bludgeoning tool to help you have quality. We have 100% coverage. We don't make any assertions in our tests, but code is exercised. Code coverage is a terrible metric for quality. It just tells you what things have run. Now, that's not necessarily a bad thing in itself, but it's not a measure of quality. Quality is still in the backs of you to think through, to factor, to maintain, to keep your tests and your code growing successfully. Code coverage is a better metric for you to know what you haven't even touched. That's a great use case for it. But be careful. Don't show this to your manager unless you like them and you don't mind them using this as part of what they show their CEO. I've seen horrible things happen when you put code coverage metrics up on a slide at a business meeting, and they're like, "Why is that low?" Like, what does that mean? Or why? Hey, we have 100%. Why do we still have bugs? Yeah, try to be in that meeting. It's Good stuff. So slides and sample code, go to rubbercitywizards.com/stuff, download the slides. All the links are there too. I know it's hard to read the URLs. I wasn't thinking of you when I put this up. Go download the slides. You can grab them from there. And this entire project is pushed up. I have the commits broken out according to my steps. Then the last commit, the most recent one on master, is the final version with all the tests running, the integration tests and stuff like that. So thank you. Any questions? Who likes testing now? Awesome. All right. Thank you very much. Thank you. Go for it. Shoot. There is a school of thought that says that if you're trying to test private methods, you've not constructed your objects. Like maybe there's something else you can extract that gets called by this object that you could test that would be used privately. That's one way to think of it. I don't always, I mean, in reality, you have trade-offs. You can do what the gesture recognizers did. If you're a subclass of UI gesture recognizers, there's a special header you import that the users of gesture recognizers don't see, just you as a subclass. You could do the same thing. You can create a special test-only header for an object, import that into your test that declares the private methods and then call them. I do think, though, that warning about private methods is good. If you're trying to test a lot of your internal private methods, that might be a hint, and this is where tests drive the design of your application. That might be a hint that you can pull that out into another object, decouple that out. Is there too much going on in this object? That's a good question to ask, but it's totally possible. And yeah, this is Objective-C, perform selector all the way. You just call methods and see what happens. And then it breaks when LLVM makes that a warning, takes it from a warning to an error, and then you'll cry, but it's all good. So, any other questions? There are no naive questions, just stupid answers, and that's my fault. So, yeah. I used Kiwi a lot. I saw the writing on the wall when the warnings happened with iOS 6, and I began to realize that Kiwi is a, through the magic of television, I happen to have, I didn't even know if I'd ever get into this, but I took a Kiwi project, the actual Kiwi project, and I brought it in here, and we can actually run the tests and see what happens. It's possible to use Kiwi with this whole mechanism. Kiwi right now it's most reliable with the old send test framework, which kind of works with the new tools that Xcode has. It's not totally compatible. You should upgrade to XCTest. Kiwi has a plan to move to XCTest, but the problem is that what makes Kiwi interesting is that if you've ever used RSpec for Ruby, things like that, you define your methods in this way, where you have these outer blocks, you're using a lot of blocks, you have hello, all this stuff's happening for me here. You have these if statements, and you inside the if statement you have a bunch of things that you do, and you make these assertions that say, oh, whoa, yeah, there's a lot of, this is a bad example because it's testing actually before blocks in Kiwi. But the idea is that you're nesting steps inside themselves. It's a very interesting way of organizing your tests, and I'm a fan of it. The problem is that Xcode cannot tell what you're testing here. So the running a single test at a time feature that Xcode has doesn't work. And it won't work. I don't know how it will work because of all the preprocessor magic that Kiwi does. So it's up to you. That said, the maintainer of Kiwi is committed to going forward with this. I like the project a lot. I like the style of testing. But I think if you're just starting out, I would recommend just doing XCTest straight, because that gives you, you're closer to the metal. You're playing in Apple's sandbox without any extra toys, which is a great way to learn. Some of the pain and friction involved in unit testing before was trying to bring in extra stuff. And hopefully, let's file bugs about this, even OC mock will show up in there, so we don't have to try to figure out how to put it in and link it correctly and all that stuff. I'd love to see that happen so it reduces the friction at even that level. So that's my quick overview of Kiwi. I'm a fan, but it doesn't quite work yet. We good? Thank you. You've been great. Thank you.